So you've learned a few skills as a developer, but you feel like you've learnt those skills in isolation. And now you want to see what it takes to build a production-grade application that's going to scale from start to deployment. In this video, we're going to do just that. We're going to bootstrap our API, and it's just going to be a simple little to-do list, and we're going to use MongoDB and Fastify to do that. The reason I'm going to use Mongo is because I need to move this application into something that is going to go into production, and that has a requirement for MongoDB. And then we're going to Dockerify this application, and we're going to use Docker, Docker Compose, and we're going to use Caddy Server, and then we're going to deploy this on a DigitalOcean droplet. I'm going to manage all of my tasks on a Trello board, just as I would if I was doing this in my day job. So let's start off by having a little overview of the tasks that we need to complete to get this application finished. So first up, we need to bootstrap the application, and you can see here we have this little checklist, and DOD is a definition of done. So once we've finished all 3 items on this checklist, we can define this task as done, and then we can move it over to the done column. Secondly, we need to connect to MongoDB, and that's pretty standard for most applications. Next, we need to add Graceful shutdowns, and this is so our server will shut down gracefully when it gets a kill signal. This is pretty standard for most production-grade applications, and it just means that you can close off things like database connections, or you can stop listening to messages on a queue, or stop publishing messages to, say, a message bus. Next, we're going to configure Husky and commitlint, and this just means that we can run tasks when we make commits, and all of our commits are going to be prefixed with semantic tags such as feat, security, and test. Next, we're going to configure Prettier, and this means that all of our code is going to follow a certain format. Next, we're going to configure our to-do module. And this is nothing special, but you're going to see how I like to structure my REST APIs so they do scale in the real world. Then we're going to add some schemas, and this is going to be for validation, but more importantly, it's going to populate our Swagger docs. And most production-grade applications are going to have some sort of documentation, and if you can automate that documentation, that's a real big win. Then we're going to configure Docker, we're going to configure Caddy Server, and then finally, we're going to spin up a DigitalOcean droplet and deploy the application. Your application will be deployed with an SSL certificate, and that's thanks to Caddy Server. So let's get started bootstrapping this application. So I'm here in the terminal, and I'm just going to make a directory, and I'm going to call this to-do app. Then I'm going to cd into to-do app. Then I'm going to open this up in VS Code. The first file that I've dropped in here is this notes file. And if you want to follow along with this tutorial, you can go to the description below and you'll see a link to a GitHub repository. In that repository, you'll see this notes file, and this has some commands that you can use to follow along, and it just means that you don't have to type them out manually. So we have our install command here, we have an install for development dependencies, we have a command to initialize TypeScript, and then we have some other commands to initialize Husky and Prettier and all that sort of stuff. Next, I'm going to open up my VS Code terminal, and I'm going to say yarn init, and this is just going to initialize a new package. I'm just going to press enter on all that, and this is going to give us a package.json. Then I'm going to go into my notes, and I'm going to grab this first install command here, and I'm going to install these dependencies. While they're installing, let's go over to our task board, and you can see our first task here is to bootstrap this application. So let's move that into doing. It's always a good idea when you're working in a team especially to just assign yourself to this card. So in Trello, it's just going to be in members, and you can put yourself on the card. You can also leave a little note here to say, I'm working on this task. If you were working in something like Jira, you could assign yourself to the task. And this just means that somebody else isn't going to come grab this card, and then you're both working on the same thing at once. That'd be a bit of a waste of time. So our dependencies have finished installing. Next, let's install our development dependencies. So our development dependencies have finished installing, and then we can initialize TypeScript, and we can do that with npx tsc init. And then this is going to create a tsconfig file for us. We're going to change a few things in this tsconfig file throughout the video. However, the first thing that I'm going to change is this out directory. And I'm just going to uncomment this, and then I'm going to change this to build. And the reason I'm going to change this now is because if you forget to do this, and then you go to build your application later, it's just going to build each JavaScript file alongside its TypeScript file, and then going to clean that up is really annoying. While we're in here, I'm going to touch a .git ignore, and touch is just to create a file. And in the git ignore, I'm going to add my node modules, and I'm also going to add my build, and then I'm going to add .n because we're going to have a .n file later on. And then in package.json, we can add some scripts, and then we can add a build script, and then we can just set this build script to TSC, and this is the TypeScript compiler, and then this is going to compile your application for you. So the next thing I want to do is in the root directory, I want to create a new folder, and I want to call this src. And then inside of the src directory, I want to create an app.ts. And then inside of app.ts, I just want to say console.log hello world. And now we just need a way to run this file. So to run this application, I'm going to come in and I'm going to make a script called dev. And then previously I would have used tsnode dev, but now I'm going to start using tsx, and we're going to point this to our app.ts. So this is in src/app.ts. Now we can type yarn dev, and you can see here we get hello world, and our application is running. So the first thing we need to do is to get a running server, and then we need to add a logger and then config with validation. So to get a running server, we need two parts. We need to create a server, and then we need to run that server. And I'm going to split these two parts out, and this is going to make testing our application a lot easier. So inside of source, I'm going to create a new directory, and I'm going to call this utils. And then inside of utils, I'm going to create a new file, and this is going to be called create server.ts. Then inside of create server, I'm going to say function create server. And then I'm just going to export this as a named export. Then at the top, I'm going to import Fastify from Fastify. And I'm going to say const app is equal to Fastify. Then I'm going to execute this. And then at the bottom here, we can return app. Now, if we come back to app.ts, I can say function start server. And then down at the bottom here, we can execute start server. And this needs to be an async function. Next, I can say const app is equal to await create server. And this is going to come from utils create server. Let's actually call this server. It makes sense that a function called create server returns a property called server. Then we can say server.listen. And I want to listen on port 3000. And I want to listen on the host 0.0.0.0. Make sure you define this host here as 0.0.0.0. Otherwise, Docker will not work. If you just have this as localhost, Docker won't know what localhost is. Docker only knows what 0.0.0 is, and that is the equivalent to localhost. Next, we can console.log app is listening. Okay, so let's try this. Yarn dev. And we get app is listening. Let's try curl this. So curl HTTP. And then we are on port 3000. And we have no health check endpoint, so we should just get a 404. And yep, we get a 404 back, so our application is up and running. Let's change the port here to 4000. I think 3000 is typical for UIs, and so this is just going to make it a little bit less confusing. And when we save, our server isn't restarting here. And the reason for that is because in our package.json, we need to add tsx watch. And this just means that tsx is going to watch our files and restart the server. So we need to stop here, and then we can yarn dev again. Then we can save, and our app should restart. Yep. So we have a running server, so we can check that. The next thing to do is to create a logger. So I'm going to come back, and inside of a utils folder, I'm going to create a new file, and I'm going to call this logger.ts. And then I'm going to import Pino from Pino. Then I'm going to export const logger is equal to Pino, and then you can execute this, and now we can put in some options in here. So I'm going to format the timestamp, and I'm going to format this with a function, and then my function is going to return a string, and I'm going to start with a comma here. Then I'm going to put in some templates. I'm going to have a new date, and then I'm just going to format this as to ISO string. Let's use this logger and see if we like this format. So instead of the console log here, I can say logger, and make sure this comes from util/logger, not typegoose. .info. And I'm going to change these to backticks. And you can see we get a log here. So this is the ISO string. Let's change this dot to date string and see if we like this better. So I think this is a little bit long and it doesn't have a time. So I'm just going to add the to ISO string and then I'm going to leave it at that. You can also redact properties in Pinot. So you might want to log something such as a database connection string, but you also want to redact it. So you can do that with redact, and then you can pass this an array here. So I want to redact my host name, and then I can put in a string here. And when we save that, you can see we get host name, and now it's redacted. Let's go back to Trello, and we've configured a logger. The next thing we need to do is to get some config, and we need to get that config with validation. So inside of utils, I'm going to create another file here, and I'm going to call this config.ts. And inside of config, I'm going to import env schema from env schema. And I'm also going to import from at Sinclair/typebox. And I want to import type and static. So nschema is going to get our environment variables from a .env file, and it's also going to allow us to pass a JSON schema. And so we're going to get type-safe environment variables, and our application isn't going to start if it's missing an environment variable. So it's going to notify us straight away. You can just make a normal JavaScript object that is a JSON schema, but I'm going to use Typebox to help me do that. And the reason for that is because I'm then going to get some type safety for our environment variables. So I'm going to say const schema is equal to type.object. So the syntax of Typebox is a lot like, say, Zod. And then we're going to have a port. And a port is going to be type.number. And then I'm going to say the default is 4000. We copy this down. Then we're going to have a host, and a host is going to be a string. And then the default is going to be 0.0.0.0. Then we're going to have a database URL, and then this is going to be a string. And we're not going to have a default for this. So now I can build an interface out of this schema. So I can say type env is equal to static. And then I can say type of schema. Now if I hover over env, you can see here we have a type with our port, host, and database URL. Next we can say export const config is equal to env schema. And we can pass in our schema here, and then we can say .env, and I want to set this to true, and this just means that we're going to get our properties from a .env file. Now if we try use this, we can say config dot, and we don't get any type safety. The reason is because env schema requires a generic here, and we have this env generic that we can pass in. Now if we say config dot, we get some type safety here. Let's go use this inside of our app.ts. So I'm going to say config, and make sure this comes from util/config dot port. And then for our host, we're going to say config dot host. And now let's save this. And you can see here that we're getting an error because we're missing our database URL. Let's fix that. I'm going to create a new file. I'm going to call this .env. And then I'm going to paste in my database URL. This is just a connection string for Mongo Atlas. Before you let me know in the comment section that I'm showing my password here, don't worry, I'm going to change this before I upload this video. If you don't have a running instance of MongoDB or Docker, now is a good time to pause the video and go make sure you have those running. So let's stop our application and we can try start this again. And you can see that we have a nice log here and our application has started. So let's say this config with validation is done, and now we can move this over to done. The next thing we want to do is to connect to MongoDB. So inside of utils, I'm going to create another file here, and I'm going to call this db.ts. Inside of db.ts, I'm going to export two functions. So I'm going to say export function connect to DB. And then I'm going to export function disconnect from DB. And connect actually needs to be an async function. And inside of our connect function, I'm going to add a try catch block. And I'm going to catch this error. And then I'm going to try await Mongo dot connect. And then I want to connect to our config dot database URL. And then I want to logger dot info connected to database. I'm actually going to make a security flaw here. So I'm going to add some options to our log, and I'm just going to say database URL. I'm going to add that there. If we catch an error, I want to process.exit, and I want to exit with a status code of 1, which means we exited with an error. And I also want to logger.error, and I just want to log our error out. So when we disconnect from the database, I just want to return mongoose.connection.close. And this is just going to close our connection to MongoDB. Okay, so inside of our app.ts, after our server starts listening, I want to await connect to DB, and we can execute that function. Now we can save this. And then when we connect to our database, we're going to get a log here connected to database, but you can see that I've also added my Mongo connection string here. Now, this may seem silly, but I see people doing this and it's a really bad practice. Either redact this string here if you want to add it, or mask it, but make sure you're not exposing too much of this string, and especially not the password, because you don't want to have your Mongo connection string passwords in the logs. I know this seems silly, but I've actually seen people do this. So I'm going to fix this here by removing it. Just be careful with what you are logging. Okay, so let's go back to our task, and we have connect to MongoDB, and we've finished that. The next thing to do is to add Graceful shutdowns. So we need to stop the server instance. We also need to disconnect from Mongo, and then we need to listen to these signals here. So let's copy these signals, and I'm going to come back to app.ts, and I'm going to add a const signals is equal to an array, and then I'm going to put these signals in here. So we want to listen to all of these signals and then run a specific function when we hear one of these signals. So I'm going to say async function graceful shut down. And then inside of this function, we're going to have one argument, and that's going to be an object. And then this object is going to have this signal. And we're also going to get our server instance. So we need to type these. A signal here is just going to be one of these signals up here. So I could say that signal is going to be a type of signals. And then we need to pick one element out of the array. So I'm going to put a number in here. So now you can see that signal is just going to be a string, but that's not very specific because we know signal has to be one of these three things here. If we say as const, then signals is not just an array of strings. It's going to be literally one of these three strings here, and it's going to be read-only. So now if we hover over a signal here, it's going to be one of the three strings here, and that's just a little bit more clear about what signal is. Next, we want server, and we know that we get a server from our create server function. So this is going to be the return type of create server. So if we hover over server, you can see here that it's not returning a promise, but create server should return a promise. Let's go fix that. And I'm going to make sure this exports an async function, because you can see we're awaiting it here. We shouldn't await a function that doesn't return a promise. That makes no sense. Now we can see server is a promise, but we want the resolved promise or the awaited promise. So I can say awaited, and then we can put these inside of the awaited generic. And now our server is going to be our Fastify instance. Okay, so inside of Graceful shutdown, I want to call await server.close I also want to logger.info, got signal, and then we can print out the signal that we got, and then we can say goodbye. We also want to await disconnect from DB, and then we can call process.exit, and we can exit with a status code of 0, which just means we exited without an error. Now we need to call this function. So once our server is up and running, I want to have a for loop run, and I want to say let I is equal to 0, I is less than signals.length, and then I plus plus. If you don't like for loops, you can also use a for each. I personally don't mind for loops. Then I want to call process.on, and I want to get the signals, and I want to get the ith value, and then I want to call a function that calls Graceful shutdown, and I want to call Graceful shutdown with the signal, which is going to be signals, and then I, and I also want to call it with our server instance. Okay, so let's pass in a kill signal with Control C. And you can see here we got a signal, got signal, sig term, goodbye, and then our server shut down gracefully. Start this back up. Let's go over to our task board. And we did both of these tasks, so we can consider that task to be done. The next thing to do is to configure Husky and commitlint. Let's go over to our notes file here, and we get some commands to configure Husky. So I'm going to run yarn husky install. So you can see we get an error here, fatal, not a Git repository. So let's go initialize a Git repository. It makes no sense to have commitlint configured if we don't have a Git repository anyway. So to do that, I'm going to come over to GitHub. I'm going to create a new repository, and I'm going to call this to-do app. I'm going to make this a public repository. Click create. Then we're going to get some commands here to initialize our repository. We're going to add some files. We're going to make our first commit. We're going to set the branch to main. We're going to set the origin, and then we're going to push to the origin. So the first command is git init. So I'm going to run git init. Before you do this, make sure you do have a git ignore set up. So you can see here that we have some changes. And we just want to make sure that we don't have node modules in here or our .env or anything that we don't want going up to GitHub. Now we can run git add dot, and this is going to add all of our changes to our stage. If we want to remove these changes here, so we could add individual files. So I could say git add src/app.ts, and then this would just add our app to our stage changes. But I want to add everything. So git add dot. And then I want to make a commit. So I'm going to say git commit -m. And I'm going to say this is the initial commit. Then I'm going to set the branch to main with git branch -m main. Then I'm going to set my remote origin. And now I can git push to the remote origin. And this is going to upload all of my files to GitHub. So now let's refresh this. And you can see here we have all of our files. Okay, so let's try configure Husky again. So yarn husky install. And this time we're successful, and this created this .husky file here. And inside of here we get a shell script. The next thing we want to do is to create this file here, commitlint, inside of the .husky folder. So I'm just going to run this touch command here. So now we have this commit message here. We want to add this script here to our commit message. So this script here is just going to run the husky sh script that lives in the underscore directory, and that exists here. So that is this husky sh script here. And that's just going to do some setup for us and stuff. And then we want to run our script. And this script is going to be npx, and we're going to run commitlint. Next, we need to modify that file so it's executable. So I'll show you what the error will be if you don't do that. So I'm going to say git add dot, then I'm going to say git commit -m, and I'm going to say with Husky, and you can see here that we get an error that this didn't run because it's not executable. So now we can make this executable. And let's try this again. Git add dot git commit -m with Husky. And now we get a new error, and this is saying that we need to add a commitlint config. So to do that, I'm going to touch commitlint config.js. Then in here, I'm going to say module.exports equals. And then we're going to have an object, and then I'm going to say exports. And then I'm going to have an array here. And I'm going to have at commitlint slash config conventional. Save that. Let's try this again. Git add dot. Then I'm just going to commit this with Husky. And now we get a new error. And this is saying subject may not be empty, and then the type may not be empty. So let's try this again. So I'm going to say git commit -m. And here I'm going to say feat with Husky. And now this commit is successful. So now we can say git push. And we can come back to GitHub. And you can see this commit here is prefixed with feat. So the reason you'll do this is because it tags each one of your commits with what it is. So if you're adding a test, for example, then you would say test and then the file or function that you're testing. If it's a security fix, you would say security and then what it is that you fixed. This is going to add meaning to your change logs and your commit history. Let's come back to our tasks. I didn't move this into doing, so that's minus points. We can move configure Husky and commitlint to done. Now we need to configure Prettier. Let's open up our notes file again. And we have some commands here to configure Prettier. So we just want to echo a Prettier rc.json. And then we just want to add some square brackets to that. So I can copy that command. And then this is just going to make a Prettier rc.json. And it just has those square brackets. You don't have to use that command, obviously. That just makes it a little bit easier. Next, we want to touch a Prettier ignore file. Next, we want to touch a Husky pre-commit file. And this is just going to make sure that all of our changed files are formatted with Prettier. And we obviously need to chmod that file. And while we're here, let's grab this script here, and we can put this into our pre-commit. And this first part here is exactly the same that we did in commit message. The second part is just going to run npx lint staged. Okay, so we want to add some files to our Prettier ignore. The first one is just going to be our node modules. And then we also want to add our build directory. And we also want to add .nyc output. And .nyc output is going to get created by Vitess when we add some tests. Next, we can configure our Prettier rc.json. And this is where we would configure our rules. So I want to say semi is going to be true, because I don't mind semicolons. And then I want to say single quote is true. So you don't have to use these rules, obviously. You can define these rules to match your preferences. So now if we go save a file, it's going to follow our Prettier rules here. And you can see the double quotes are changed to single quotes and semicolons are added. The next thing we need to do is go into our package.json. And we need to add a rule here for lint staged. So I'm going to say lint staged. And then I'm going to add **/*. And I want this to be Prettier. And I want it to write and ignore unknown. Okay, so let's commit this. Git add dot and then git commit -m feat with Prettier. And we can git push. Okay, so we can consider configure Prettier to be done. The next thing to do is to configure a to-do module. And this is just some business logic that we can play around with. So you should be able to create a to-do item, and then that item should be tested. So inside of my source directory here, I'm going to create a new folder. I'm going to call this modules. Inside of modules, I'm going to create another folder. I'm going to call this to-do. So this is how I like to structure my REST APIs. I'm going to have a modules folder, and then inside of that module folder, I'm going to have each module. So if you had an e-commerce application, for example, you might have some users, you might have some products, you might have some sales. I would have each of those in its own module. In each module, we're going to have roughly the same files. We're going to have a controller. So I'm going to say todo.controller.ts. We're going to have a service. So I'm going to say todo.service.ts. We're going to have a model. So I'm going to say todo.model.ts. We're going to have some schemas. So I'm going to say todo.schema.ts. And then finally, we're going to have some routes. So I'm going to say todo.route.ts. And in Fastify, each one of these modules is actually just a plugin that's hooked up to our application via the routes. So I'm going to start off in the route file. I'm going to say export function to-do route. And then our to-do route is going to take our app, and this is going to be of type Fastify instance. Then we're going to have some options, and this is going to be Fastify plugin options. And then we're going to have a done function, and this is just going to be a function that returns void. At the end of this plugin, we need to execute the done function. And I'm just going to say for now app.get, and I'm going to have a get request on slash that just returns hello. And then we can go hook this route up inside of our create server. So I'm going to register a module. So I'm going to say app.register, and I want to register our to-do route. And then I want to add some options here. I'm going to add a prefix, and the prefix is going to be /API/to-dos. So anything inside of our to-do route here is going to be /API/to-dos. So this route here is not my application's port and then slash, it's actually /API/to-dos. Okay, so next let's go configure our model. So I'm going to say export class to-do. And the reason I'm exporting a class here is because I'm going to be using TypeGoose, and that's going to allow us to export a model and an interface that matches that model. I'm going to have an app prop, and this comes from TypeGoose. And then I'm going to have a title property, and this is going to be a string. I'm going to add a type, and I'm going to say this is a string. Then I'm going to add a required, and then required is going to be true. I'm going to copy this down a few times. I'm going to have a short ID, which is also going to be a string. I'm going to have a checked property, and this is going to be a Boolean. Then my type here is going to be Boolean, and I can remove this one here. Next, we need to export a model. So I'm going to export const to-do model is equal to get model for class, and then the class is to-do. Next, we can pass in some options, and I'm going to say schema options, and then I'm going to say timestamps true, and then this is going to give us our created app and updated app. So we have a few errors here. So this error says experimental support for decorators is a feature that is subject to change in the future release. Set the experimental decorators option in your tiers config to remove this warning. Let's go into our tiers config file, find experimental decorators, and then we can set this to true. Let's go back to our model, and you can see that we still have an error here. It says property title has no initializer that is definitely assigned to this constructor. So to fix this error, we need to go back into our tiers config file. Then we need to find this strict property initialization, uncomment this, and then set this to false. Come back to our model. Now let's try start our application again, yarn dev. And our application starts successfully, so we are good to go. So in this structure, a request is going to come in, it's going to come in through our route, and then our route is going to call a controller, and then our controller is going to call a service, and then a service is going to call our database. So this is how I like to keep my logic separated. Controllers are going to handle the business logic, and then database calls are only ever made from services. This means that I can make services that are very small and easy to add metrics to. It's really important that you are measuring your database response time. With something like Prometheus, if your database starts taking a long time to respond, that's a problem that you're going to want to know about straight away, and you're going to want to rectify that. If you have a route that is very slow but does many database calls, it can often be quite difficult to isolate why it's slow, and it could just be one of those database calls. If you have it separated and you have metrics on your services, it's going to be easy to tell which service is responsible for the slow request. So instead of our controller, I'm going to say export function create to do. And then this function here is going to take a request and a reply. And we can type our request here as a Fastify request. Then we can type our reply as a Fastify reply. Next, we want to try and we want to catch. We're going to catch an error here. If we do get an error, we want to logger.error. And then I want to add my error, and then I want to add a message here. I also like to prefix my errors with where it came from. So this should actually be to create to do handler. So I'm going to copy that, and I'm going to say this is in create to do handler, and then the error is going to be error creating to do. So when I see this error in the console, I know exactly which function it came from. So the next thing I want to do if I encounter an error is return, and I want to reply. And then I'm just going to reply with a status code of 400 for now, .send. And I want to send a message. There's error creating to do. And this should be reply.code. You'll probably want to check what the actual error from the database is here, and then reply with the appropriate error. So for example, if you had a conflict, you would want to reply with a 4 and 9. So inside of our try block, we need to make a request to the database, but we don't make requests to the database inside of the controller. This is just for business logic. So we need to make a service that does make the request to the database. So I'm going to export function create to do. And this is actually going to be an async function. Then I'm going to return to do model.create. And I want to pass in some input. So I'm going to input. And this is just going to be any. So I'm going to add a comment here that says to do type input. Then I'm going to spread my inputs. And I want to populate a short ID. So I'm just going to use nano ID to do that. So I'm going to say const short ID is equal to nano ID, and then execute that. I want to prefix my nano ID with something that identifies the actual resource. So I'm going to put some strings here. Then I'm going to make this executable JavaScript, and then I'm going to prefix this with to do. And then I'm going to put my short ID just above my input. And then this is going to create a to do for us. So we can go use this service now. So I'm going to say const to do is equal to await create to do. And then we want to pass in our request body. So this needs to be an async function. So I want to pass in a request dot body. So this is not very good practice here. What we're doing is we're just taking anything in the request body, and then we're going to send that off to our database without doing any sort of filtering on the data that's in that body. We're going to add a schema later, and that's going to make sure that you can only put specified fields in that body. And then lastly, we just want to return this to do. Okay, so let's go hook this up to our router, and I want this to be a post request. And then I want to pass in some options here. We're going to put our schema in this object bracket here later. Then this is going to be create to do handler. So I'm here in Postman and I want to create a to-do. So I'm just going to say the title is hello world. Send this off. And we get an error back here. Let's go check our console and we get a path checked as required. So let's go back to our model and we have checked as required. So let's remove required here. And I'm just going to say default is false. Let's try this again. And now we get back a to-do. Let's omit the title here. And we get a database error. This is not really what we want. We actually want a response that tells us title is required. But I think we're better off not sending this request to the database if the title isn't there. I don't think this logic should be on the database. We should catch this error earlier on. And we're going to use a schema to do that. So let's come back to our task. So we've created to do, and we need to add a test, but I think we should add schemas before we add that test. So I'm going to move schemas in as well. So inside of my to-do schema, so what I want to do in here is I want to define a schema for this route. And this schema should define two things. One, what is the expected input for this route? And then two, what is the expected output for this route? So I'm going to export const create to do schema is equal to an object. And then I want to have some tags here. And this is going to be for our Swagger docs. I'm going to say to do. And then I'm going to have a description. And this is just JSON schema. Creates a to-do resource. And then I'm going to have a body. And my body is going to be type. And this comes from typebox.object. Then I'm going to have a title. And then my title is going to be type.string. I'm actually going to add a default here. A default title. The reason I'm going to add a default here is because I want that default to be populated inside of our Swagger docs just to make them a little bit easier to use. Okay, so next I want to define a response. And we could have several different responses and we need to define those responses by their status code. So I'm going to respond with a 201 status code. And when I respond with a 201 status code, I'm going to define an object that I should be responding with. So to do that, I'm going to say const to do is equal to type dot object. Then this object is going to have a title, and this is going to be type dot string. I'll copy this down. We're actually going to have an underscore ID as well. We're going to have a short ID. Then we're going to have a complete. Copy this down a couple more times. Complete is going to be a Boolean. Then we're going to have a created at, and we're also going to have an updated at. Okay, so now for our 201 status code, we can say that we're going to respond with this type of to do. Let's go back to our routes, and inside of the options here, I can say schema, and then I want to set this to create to do schema. Okay, so let's try this in Postman again. So this still works and we get our default title, but we're returning with a status code of 200 here. But our schema says that we're going to return with a status code of 201. So let's go back into our controller and we can change this to the proper status code. So I'm going to return with reply.code. I'm going to reply with a status code of 201, which means we've created a resource. .send, and then I want to send my to-do resource. Now we're going to get schema validation on the output for our 201 response. Send this. And we're getting a 500 error here. Complete is required. Let's have a look at what is happening. So we can have a look in our schema and we have complete here. Let's go back to our model. And it's actually called checked here. Let's change this to complete. I think that's a better name for that property. Let's come back to Postman. We can try this out and we get our to-do item back. Okay, so we've added schemas. Let's move that over. And the next thing to do is to create a test for the route. So inside of our to-do module, I'm going to create a new folder. I'm going to call this __test_, and then I'm just going to have one test. So I'm going to call it exactly what I am testing. So I'm going to say create to-do.test.ts. How you structure your test files is up to you. If I'm going to test something end to end, say a full integration test, then I'm just going to have one of those tests per file. And so I'm going to call it something like create to do. If I'm just going to test everything, say in my controller, then I might make it a to-do.controller.test.ts. So we're going to be using vytest. And so we need to import our describe and int blocks manually. So I'm going to import from vytest. And I'm going to import describe it. I'm going to import vi. And I'm also going to import expect. If you're familiar with Jest, vytest is very similar. It's just a little bit nicer to work with. I'm going to have a describe block. And then inside of that describe block, I'm going to have post. And then I'm going to say post/API/to-dos. And then route. So we're testing the post/API/to-do route. Then we're going to have a callback. And I'm going to say it should call the create to do service. And I'm going to mock out this create to do service. And then I'm just going to check that my mock has been called. So testing with Fastify is really easy, especially because we split out the creation of our server from the actual running of our server. So we can create a new instance of our server, and then we can just inject requests into it. So I can say const server is equal to await create server. And this comes from util/create server. And then our it block here needs to be async callback. Then I want to call await server.ready. And now we're good to start injecting requests. So I'm going to say const response is equal to await server.inject. And then we can pass in an object here. So the method is going to be a post request. And then the URL is going to be /API/to-dos. And then we need to define a payload. So I'm going to say const payload is equal to, and the only payload to create a to-do is just a title. So this is going to be a test to-do. So the next thing I want to do is to spy on my create to-do service. The reason I want to spy on this and mock it out is because one, I want to see what it was called with, and then I want to mock it out because I don't actually want to call the database. That means I'm going to have to set up a test database, and it's just a big faff that I don't want to deal with. So I'm going to say const create to do spy is equal to vi.spy on, and I need to import my to do service. So import star as to do service from to do service, and I want to spy on my to do service, and then I want to spy on a method in that service, and that method is called create to do. Now we can say expect create to do spy dot get mock name to equal, and then I want this to equal create to do. Let's add a command so we can start running this test. I want to add a test script, and then this is just going to run vi test. Stop our server and run yarn test. Okay, so our test is hanging here, but yeah, it's timed out. The reason it's timing out here is because it's trying to send requests to the database, but we don't have a connection to the database, so it can't send those requests. That's fine. We can mock out the service that actually makes the request. This is another good reason to separate your database calls into a services file because it makes mocking them really easy. So we have a spy, and now we can set up the mock. So I'm going to say create to do spy.mock sold value. And then I want to mock this with a to-do object. So let's go define that. So const to-do is equal to, and now we need some properties in here. So I'm going to say underscore ID. This is going to be a mock ID. Copy this down a bit. I'm going to have a title. It's going to be a mock title. I'm going to have a short ID. And we can use nano ID here. Then I want to have a complete, and this is going to be false. I want to have a created at, and this can be a new date dot to ISO string. Copy this down, and then this can be updated at. Okay, so our test is passing here, and that's good. TypeScript is complaining, so you can either add a tsignore here, or you could fix this by coming into our to-do service, and then we can just define what create to-do returns. So I can say create to-do returns a promise with a to-do, and to-do comes from the to-do model. Now if we come back, then TypeScript is now happy. We still need to go back and update this to-do item here to type the input. Okay, so let's add 2 more expect blocks. So what do we want to test here? We want to test that our create to do service called with the correct payload, and we also want to make sure that a response here is correct. So I'm going to say expect response, and I want to get the JSON version of this response. .to equal, and then it should just equal our to do. Now I want to expect create to do spy.to have been called with, and then I just expect it to be called with our payload. Let's save this. And our test here is failing. We're getting an internal server error. Created at is required. And it looks like we have a problem here. Created at. Save this, and our test is now passing. This is why I want to add the schemas before I added the test, because I knew the schemas would be the #1 reason our test failed, which is good. We want to make sure that our schemas are correct. Okay, so we have a passing test here. Let's come back to to-do service, and we can type out our input here. And we know what our input type is going to be because we're typing it here inside of our body. So I want to export type create to do body is equal to static, and static comes from typebox, type of create to do schema dot body. Now if we hover over this, we should just get a title, which is a string, which is perfect. So we can say input is a create to do body, and now input here is just a string title. Let's do the same with our controller. So inside of Fastify request, I'm going to add a generic, and then I'm going to say my body here is create to do body. Now if we hover over this, you can see our body is a title, which is just a string. We've added a test here. Let's tick that, and now we can define that as done. The next thing to do is to add Swagger docs. Because we've already defined our schema, adding these Swagger docs is really easy. So you come back to create server, and I'm going to import Swagger from at Fastify/Swagger. Then above our route here, I'm going to app.register, and I'm going to register the Swaggerify plugin. Then we're going to pass in an object here, and I'm going to set a route prefix, and I'm going to set this to /docs, and this is just the route that our docs are going to live on. Next, I want to set some Swagger config, And I want to set some tags. And then our tags is going to be an array of objects. And then a tag is going to have a name. And then this is going to be to do. Under tags, I want to set some info. And this is just info that's going to appear at the top of the page. So we're going to have a title. This is going to be to do. We're going to have a description. And this is going to be a simple to do app. And then we're going to have a version of our application. So we could just type this in here, so 1.1.1, but this is going to be quite annoying because when we bump our version in the package JSON, I want that to be reflected automatically in our Swagger docs. So I'm going to import from our package.json, and I want to import the version. And we get an error here from TypeScript, and it says we can't import JSON modules. We need to set resolve JSON module. So let's come back to our tsconfig file. We can find resolve JSON module, uncomment that. And now TypeScript should be happy, and we can use this version here. We can remove that, and then our version is going to be set automatically. That's that. I want to set some static CSP, and I want to set this to true. And this is just going to set some content security policy rules for us. Next, I want to say expose route, set this to true. If you'd like a video on CSP headers and their security implications, let me know in the comment section below. It's a video that I've been thinking about doing because I think it's really important. Let's start this application back up, yarn dev. Let's go over to the browser, and I'm going to go to localhost port 4000/docs. And you can see that we get our Swagger docs here. We have one resource, and this is to create a to-do. We have a sample payload with our default title, and then we have our 201 response here documented. If you have other responses, say 404 or 400, you want to document all those possible responses here as well. Let's refresh this page here, and we can have a look at the network request that come in for index.html, and we want to look at the headers. And you can see here we have content security policy, and this is what we get by setting the static CSP option to true. And this is just going to make our docs a little bit more secure. So I've done a lot of work here. I have a lot of changes, and I haven't made a commit in a while, and that's not a good thing. You should make lots of little commits, and it's just going to be easier to see how your application has progressed through time. So I want to check and see what I've changed in here. So I want to add just this to-do controller, the model, and the route, and then the schema. And then I want to say git commit -m, and I'm going to say feat with to-do module. So the stage files will get committed, and now I can commit the rest. And I want to say git commit -m feat adds Swagger docs. In a real world scenario, when you want to make changes, you'll often make a feature branch, and then you'll push your changes to that feature branch. Then you'll make a pull request and tag your fellow teammates, and then they're going to review that pull request. And then you can merge your changes into the develop branch or the master branch. It really depends how you have your Git set up. Let's push these changes. And we can come back to our taskboard. We've added our Swagger docs here. The next thing to do is to configure Docker. So the first thing we need to do is to create a Docker file. So I'm going to create a new file, and I'm going to call this Docker file. So your Docker file is going to create an image, and then you need to start that image and have it running in a container. So you can do that with the command line, but I find it much easier to use a Docker Compose file to do that. So let's create the Docker file first, and then we'll create the Docker Compose file to start up our container. So I'm going to say from, and then I'm going to define a base image. So we're building a Node application. So I'm going to say Node, and then I'm going to use version 16, and then I'm going to use the Alpine version of that image. And the Alpine version is just a bit smaller, and this means that your containers are going to be smaller. Next, I want to add package.json, and then I want to add package.json and package lock into a temporary directory. I'm going to run yarn install, and then I'm going to get those node modules and then move them into our source directory. So I'm going to say /tmp/package.json. And I'm also going to move our yarn lock, and I'm going to move this into tmp/yarn.lock. And then I want to run a command. So I'm going to say run cd/tmp and yarn. And I want to run this with an argument of pure lock file. Then I want to add / to src. And then I want to copy the node modules out of our temp directory into our source directory. So I want to run cp-a/tmp/node. So we now have node modules in here because we run our yarn command. And I want to move this into src. And then I want to set the work directory. And I just want to set my work directory to /src. Then I want to run the build script. So I'm going to say run npm run script. And I want to run the build script. Then I'm going to expose port 4000. I'm going to remove this later. I just need to expose this now so we can test this Docker file locally. So I'm going to add a to-do rm before deployment. We don't need to expose this port because we're going to use Caddy to reverse proxy into the Docker container. Then I want to run cmd and I want to run node. And then I want to run build/src/app.js. Okay, so this Docker file is going to create an image. And now I want to create a Docker Compose file to start our image so we can have a running container. So I'm going to create a new file, and this is going to be docker compose.yml. And I want to set a version here, and I want to set this to 3.7.7. Then I want to set our services. And the first service I'm going to have is to do app. And then I'm going to have a container name. And my container name is just going to be to do app. Then I'm going to have a restart unless stopped. I'm getting this error here because this needs to go back one level. So let's fix all this stuff here. Then I want to set an environment variable. So I'm going to set environment, and then I want this to be node n, and then the value is just going to be production. Then I want to set the build context. So I'm going to say build, and then I want the context to be just /. And then I'm going to set some ports here as well. So I'm going to say ports, and I'm going to say 4000 to 4000. So this is going to map Docker's internal port of 4000 to our external port of 4000. That means that locally we can hit port 4000. That's going to go into the container, and then the container is going to request port 4000, and then it's going to respond with a request from the application. We're going to remove this ports later. We don't need this when we reverse proxy in with Caddy. Okay, so we can try this with docker compose up, and I'm going to pass in the build flag. And this is not version 3.7.7, it's just version 3.7. Let's try this again. So this is going to build out our image, and then it's going to start up a container for us. Okay, so we have a terminal here, and our terminal is attached to the instance. If you don't want to have your terminal attached, you can pass in the /d flag or the -d flag, and this is going to run it in detached mode. But you can see here, our image has started. So we should be able to go over to port 4000. We can restart this, and our application here is running on port 4000. So this means that our Docker file and our Docker Compose are both working correctly. Let's add a commit here. So I'm going to say git add dot, and then git commit -m. And I want to say feat docker or adds docker. Now we need to make a few modifications to our Docker file before we can deploy. Let's first remove these ports. We don't need those anymore. And we can do this to our Docker file as well. And then inside of our Docker Compose, we want to have another service. And this other service is going to be Caddy. So for Caddy, we're going to use an image of Caddy/Caddy, and I'm going to use 2.1. So 2.2.1, and then I'm going to use the Alpine version. I'm going to have a container name, and my container name is just going to be Caddy Services. Then I'm going to have a restart, and I'm going to use unless stopped. Then I am going to expose some ports here. So I'm going to say ports, and I want to expose 443, and I want to expose that to port 443. So this is going to expose the internal port of 443 to the external port, and we need to expose port 443 for HTTPS connections. We also want to expose port 80, and we want to expose port 80 so we can accept a request on HTTP, and then we can redirect that user to HTTPS. Next, we need to set some volumes. So I'm going to say volumes. We have one here called pwd. So pwd/caddy file. And we want to put this in /etc/caddy/caddy file. And we need to create this caddy file. So let's quickly touch that so we don't forget. Then we need another volume here. So $pwd/site, and I'm going to put this in services. We need a caddy data, and I'm going to put this in /data. Then we need a caddy config, and I'm going to put this in config. So now we need to create these volumes. So I'm going to say volumes. And we need our caddy data, and we need our caddy config volumes. Okay, so let's now go work on our caddy file. So this caddy file is kind of like a Docker file, except it's specifically for Caddy. So Caddy is an alternative to something like Apache or Nginx, but it's going to grab an SSL certificate for you, and it's going to manage all that process for you. It's just much easier to use, and you'll see that with the configuration we have here. So I want to define the domain that I'm going to be using. So this is going to be todo.tomdoestech.com. So you obviously need to use your domain in here. So if your domain was, say, example.com, then you would put example.com in here. Then I want to reverse proxy, and I want to reverse proxy to to-do app on port 4000. So the reason we have to-do app here is because we have a container called to-do app running. So we can request this container to-do app, and I want to make a request to this container on port 4000. Then I want to set one header down, and that header down is going to be strict transport security. And then I want to set max age is equal to 315.36.000. So that's 315.36.000. This header here is going to help improve our site security. Okay, so let's say git add dot. Now I'm going to make a commit, git commit -m feat, and I'm going to say adds caddy. Then I'm going to git push. The last thing I'm going to do is to just make a little deployment script. And this just means that we need to run one script. We don't have to run a few commands or have to remember what those commands are. So I'm just going to create a new file here, and I'm going to call this deploy.sh. And inside of deploy, I want to run git pull, and we can echo here. So echo pulling. Then I want to run docker compose up -d, and I also want to run the build flag, and we can echo building. So let's git add dot, and then git commit -m beats deploy script, and then git push. Okay, so the next thing to do is to spin up a DigitalOcean droplet. So I'm here in DigitalOcean. If you have a look in the description below, you'll see a referral link to DigitalOcean. If you use that referral link, you'll get a bit of credit. I think it's about $100 credit. You can create a droplet. And then I'm going to go over to the marketplace and I'm going to create a droplet for Docker. And this just means that I don't need to install Docker myself. I'm going to choose regular SSD. And then I'm just going to choose this $24 a month one. You can get a cheaper one here, but I find you need at least 2 gigs of RAM to install all your dependencies and everything. You might run into some issues with less RAM. You can try the 1 gig one, and if it doesn't work, then you can just resize the droplet. I'm going to select Singapore for my droplet. I'm going to use an SSH key, and I already have an SSH key on my computer. I do recommend using an SSH key over a password. It's obviously going to be much more secure. And then finally, I'm just going to rename my droplet to to-do app. Now this droplet's going to take a few minutes to spin up. When your droplet has finished creating, you want to copy the IP address here, and you want to come over to your domain name provider. If you're using a different domain provider, the interface is going to look a little bit different, but what you do is going to be roughly the same. You need to add an A record. So I'm going to click add new record. I'm going to add an A record. My host is going to be to-do. And then I'm going to add the IP address. So the next thing I want to do is open up a terminal, and I'm going to cd into /.ssh. And in here, I'm going to say SSH -i, ID, RSA, and then I want to connect to root at and my IP address. This is just going to ask if you want to actually connect to this host. I'm going to say yes. Now I can ls, and you can see the files that we have on the server. Come back to GitHub, and I'm going to copy the link here, and then we just need to clone this repository. So I say git clone. We can paste that in there. And now our repository has been cloned. We can type ls again, and you can see that we have our to-do app. Let's cd into to-do app. The next thing we need to do is to add a .env. So I'm going to touch.env. And then I'm going to open.env, vi.env. Then I'm going to paste in my database URL. You can just copy that out of your env file inside of your repository. Then I'm going to save and exit by bringing up the colon, typing WQ, exclamation mark. So we can ls again, and you can see that we should have a .env. So I can do ls -a, and now we can see our .env. Let's open this up again with vi.env, and you can see that it is there. So we can exit this. Now we can run our deployment script, but we need to modify the deployment script. So I'm going to say chmod a + x, and this is going to be deploy.sh, and this just means that we can execute it. Now we can run that with /deploy.sh, and then this is going to build and start up your images. So once your Docker images have finished building and your containers have started up, you should see 2 done messages here. So we can say Docker PS, and then this is going to list out our running containers. We can grab an ID here. Let's grab the one for the Caddy Server, say Docker logs, and then we can put in the ID, and we should see some logs here. So one log that we do want to see is this enabling automatic TLS certificate, and we want to see that it has actually gotten a certificate for us. If it hasn't gotten a certificate for you and you see some errors in here, just wait a while, and you may need to wait for the DNS to propagate, because Caddy needs to be able to verify that your domain actually points to the IP address of this server. Okay, so let's say Docker PS, and we can get our container Docker logs, and our application has started up successfully. So let's go over to the browser, and we can go to to-do.tomdoestech/docs, and you can see that we have our docs all deployed here, and we have an SSL certificate as well, and that's thanks to Caddy. So that is how to build, test, and deploy an application like we would in the real world. If you enjoyed this video, please make sure you leave a thumbs up and subscribe so you get notified whenever I release new videos. Thank you for watching, and I'll see you in the next one.